Welcome to Fix My Linux, your one-stop place for Linux tips, tricks, and tutorials. Have you ever downloaded and run a bash script like install.sh without fully understanding what it does behind the scenes? You're not alone. Bash scripts can seem like magic at first, but once you learn how they work, you'll realize just how powerful and simple they really are. In this video, we'll break it all down. I'll show you how to write your own custom bash scripts from scratch, how to execute them, and how to work with variables, including user inputs and system variables. Let's dive right in. Section 1. Creating your first bash script. Let's create our very first bash script step by step using the Linux terminal. First, bash scripts typically have a .sh file extension, so let's create a new file using the nano command, nano-helloworld.sh. You can name the file anything you like. Now every bash script should start with a shebang line. This tells Linux which interpreter to use. Type #!/binbash. Now let's start simple by printing a message to the terminal using the echo command. Echo hello world.
Section 2. Running your bash script. You've written a bash script, but how do you actually run it? There are two main ways to execute a bash script. First, you can use the bash command directly, bash helloworld.sh. You'll see your hello world message printed in the terminal. Second, you can make your script executable. But before that, let's check the file permissions. ls-l. You'll notice there's no x in the permission string. That means it's not executable yet. To fix that, run chmod +x helloworld.sh. Now it's executable. You can run it directly using ./helloworld.sh. And there's our message again, same output, but a cleaner way to execute the script. Section 3. Using variables in bash. How do you store and use values dynamically in your script? Variables in bash are simple. Just assign a value like this, with no spaces around the equal sign. Name John.
To use this variable, add a $sign before the variable name, echo hello $name.
Save the file and run it, and it'll print hello John. Section 4. Getting user input. Hard-coded variables are static. What if we want to get values from the user at runtime? We can ask the user to enter input using the read command. First, comment out the earlier variable by adding a hash symbol in front of it. Hashname equals John. Then add read name
echo hello $name.
Now when we run the script, it will pause and wait for the user to enter their name. Once the user hits enter, it prints the message using the value they just entered. Section 5. Using system variables. How do you access system-level information inside your script like the current user? Bash has built-in environment variables. For example, $user gives you the name of the user running the script. Echo. This command executed by $user. You can also use the whoami command to get the same result. Whoami. Run both and you'll see your username like Fix My Linux printed twice in my case. Section 6. Passing arguments to bash scripts. How do you pass values to your script from the command line instead of asking the user interactively? Bash scripts can accept arguments directly after the file name. Here's how it works. $0 is the script name, $1, $2, $3, and so on are the arguments passed. Let's say we update our script like this, echo $1, $2. If we only pass $1 value, only one value gets printed, and the script doesn't crash if $2 value is missing. Then we run the script like this, ./helloworld.sh, Peter Matthew. It will print Peter Matthew. That's one of the forgiving features of bash scripting. Section 7. Handling unlimited arguments. What if we don't know how many arguments will be passed? use $@ which represents all the arguments passed to the script. So update your script like this. Echo $@. Now, no matter how many values you pass, it will print them all. Example.
Hello world. SH, Peter Matthew, Harris, Harold, John Doe.
Output Peter Matthew Harris Harold John Doe, perfect for flexible and dynamic scripts.
Section 8 Basic If-Else in Bash. How do we run different commands based on a condition in a Bash script? We use the if-else statement in Bash, which works a bit differently than in other programming languages. Let's create a new script, nanoifelse.sh. The basic syntax looks like this. If open square bracket condition, close square bracket semicolon, then command if condition is true, else command if condition is false, fi. Yes, Bash requires you to close the condition block with fi. That's if in reverse. Let's say we want to check if the value stored in a variable called name is equal to John. Save the file and run it. Bash if-else.sh. And since our name matches John, the if block executes successfully. Section 9. Handling spaces in variables. What happens when a variable contains a space? Like John Doe. Well, Bash throws an error. In our case, it showed an error on line 7. There are two ways to handle this. 1. Wrap the variable in double quotes, or 2. Use double square brackets around the condition. For now, we'll simply wrap the variable in double quotes. This fixes the issue and the script works fine even when the name contains a space.
Section 10. Adding elif for multiple conditions. How can we check multiple conditions, like if a name is John, John Doe, or something else? Bash uses elif instead of elseif. Here's the structure. If open square bracket condition close square bracket semicolon, then if block command elif open square bracket another condition close square bracket semicolon, then elif block command else block command fi. We add our elif block to check for John Doe, and the script executes it correctly. In section 11, making the script dynamic with arguments. Right now, the script uses a hard-coded variable. How can we pass a value dynamically from the command line? Instead of rewriting every $name to $1, we assign $1 to the name variable like this. Name $1. Now run the script. Bash if-else.
.sh.
John. One important thing, if you're passing values with spaces, make sure to wrap them in double quotes. The correct block runs. No need to hard-code values anymore.
Section 12. Checking if a file exists. How can we check if a file exists in the current directory using a bash script? Let's duplicate our previous script and modify it. cpfelse.sh is file exist.sh. Nano is file exist.sh. Replace the variable name with file name. To check if a file exists, we use the -f flag in the condition. If open square bracket -f $file name, close square bracket semicolon, then echo file exists. Remove the elif block, we don't need it here. Else echo file does not exist, fi. Run the script. If the file doesn't exist, the script tells us so. We can confirm with ls grep file name. Now create the file using touchname.txt. Run the script again. It now detects the file correctly. Section 13. Checking. If a directory exists. What if we want to check if a directory exists instead of a file? Copy and modify the previous script. cp is file exist, sh is directory exist sh, nano is directory exist sh. Change the variable name from file name to dir name. Then change the flag from F to D. If open square bracket, $d$ name, close square bracket semicolon. Then echo directory exists. Else echo directory does not exist, fi. Run the script. If the directory exists, the script confirms it. Now delete the directory and run again. You'll get the correct output from the else block.
Section 14. Check and install package, if missing. How do you check if a package is already installed and install it only if it's missing? Create a new script. Nano is package installed
.sh.
Start with the usual shebang. Then declare a variable to hold the package name passed as an argument. Package equals $1. To check if the package is installed, we can use these commands. Let's run it. Bash is package installed sh curl. If curl is installed, it will skip installation. Now try with something not installed, like Axle. First, uninstall it. Sudo apt remove -- purge Axle. Then rerun the script. Bash is package installed .sh Axle. It automatically installs the package. Important tip: be sure to place commands like installation only inside the correct blocks. If you mistakenly place apt install inside the if block, it will reinstall even when the package is already present, which is not what we want. Always start with echo messages for testing. Once you're confident the script is working, then add real commands. Section 15. Basic for loop in Bash. How do you execute a command multiple times with changing values in Bash? We use a for loop. Let's start by creating a new script file, nano for loop.sh. The syntax looks like this. For double open parenthesis, I equal 1 semicolon, I less than equal 10 semicolon, I plus plus double close parenthesis. Do echo. This is $I time done. Here, I equal 1 initializes the variable I less than equal 10 is the condition I plus plus increments the value in each iteration inside the do and done block. We use echo to print each number. Save and run the script. Bash for loop.sh. And there you go. It prints numbers from 1 to 10.
Section 16. Using continue in a for loop. What if you want to show some message or perform some command when a specific condition is met at any iteration? Solution is use the continue keyword. Let's add an if block to check when I is equal to 3. If open square bracket $e, ec3 close square bracket semicolon, then echo it's 3 now, continuing to the next iteration. Continue fi. Now when the loop reaches 3, it prints the message and immediately continue to the next iteration. Save and run the script again. As you'll see, number 3 is handled differently and then it jumps to number 4 without delay. Section 17. Using break in a for loop. What if you want to completely stop the loop when a certain condition is met? Solution is use the break keyword. Copy the if block and this time check for when $id equals 8. If open square bracket $e equal 8 close square bracket semicolon, then echo it's 8 now, breaking the sequence break fi. Now save and run the script. The output will stop at number 8 and you won't see numbers 9 or 10 because the break command terminated the loop.
In Section 18, adding comments in bash scripts. How do you leave notes or temporarily disable parts of a script? Solution: use comments. There are two types of comments in bash. 1. Single line comments. Use the hash symbol at the beginning of the line. Hash echo. Try commenting out the echo line inside the if block that handles the number 3. Hash echo it's 3 now, continue to next one. Now when you run the script, you'll see a blank line where that message used to be. 2. Multi-line comments. For multi-line comment, wrap your block with a single quoted colon command like this. Commands to be comment out. This method disables the entire block. Save and run the script. Now even when $i reaches 8, the script continues until 10 because we commented out the break block.
Section 19. Understanding the for-in loop in bash. In many programming languages, we often need to loop through an array or a set of values. How can we do this in bash? Solution: bash has a for-in loop that works exactly for this purpose. Let's begin by creating a new script file, nanoforeign.sh. As always, start with the shebang at the top, #bin bash. Here's the syntax of a for-in loop. For I in open curly bracket 1.10, close curly bracket, do echo. This is $i time, done here. I is just a variable holding each item from the list. In this case, numbers from 1 to 10. You can use any variable name, x, y, item, anything. Just make sure to use the same variable name inside the do block. Now save and run the script. Bash foreign.sh. You'll see it loops through and prints each number from 1 to 10. Section 20. Skipping values in for-in loop. What if we want to skip certain values or customize the sequence in the loop? Solution: you can modify the range or list in the curly braces. For example, to skip even numbers. For I in open curly bracket 1.10.2 close curly bracket. This tells the loop to start from 1, go to 10, and increment by 2, effectively skipping even numbers. Save and run the script again. Now you'll see it only loops through odd numbers, 1, 3, 5, and so on.
Section 21. Looping through an array. Practical example. What if we want to loop through a list of items like package names or file names? Solution. We can loop through a bash array. Let's save time by copying the existing script. Copy for in .sh, for in example.sh, nano for in example.sh. Now declare an array like this. List open parenthesis item 1, item 2, item 3, item 4. Close parenthesis. Now try looping through it like this. For I in $list,
Do echo. This is $I, done.
run the script. You'll notice it only prints the first item. Why? Because we didn't reference the array correctly. To loop through all items in a bash array, we need to do this. For I in $open curly bracket list open square bracket at close square bracket close curly bracket. Do echo this is $I done. Now when you run the script, it prints each line as expected. This way, it loops through every item in the array.
Section 22. Introduction to case statement in bash. We've already seen how to use if-else to handle conditional logic in bash. But what if you need a cleaner and more organized way to compare multiple values? Solution. Bash offers the case statement, similar to switch case in other programming languages. Let's walk through how it works. First, create a new script file, nanocase.sh. Start with the shebang, number sign exclamation point / bin bash. Here's the basic structure of a case statement. Case value in pattern 1 close parenthesis, commands, double semicolon pattern 2 close parenthesis, commands, double semicolon asterisk, close parenthesis, default case double semicolon exec. Let's say you're checking for an operating system. Case starts the block. Each condition ends with double semicolon. The asterisk acts like an else block, and the block ends with exec, which is literally case spelled backwards. Save and run the script bashcase.sh. You'll see the message, "This is Linux OS." Section 23. Changing conditions in case statement. How does the case block behave when the condition changes? Solution. Just change the value stored in the variable. Update the variable like this. OS equals Windows. Run the script again. This time, the output shows, "This is Windows OS." So depending on the variable's value, the script executes the matching block. Section 24. Using dynamic variables in case statement. What if you want the condition to be dynamic, based on actual system data? Solution. Use variables or system commands to assign the value you're checking. Let's make it interesting. Replace the OS variable value with the uname command. OS equals $open parenthesis, uname close parenthesis. The uname command returns the system's operating system name. Like Linux or Darwin, you can test it by running uname directly in your terminal. Save and run the script bashcase.sh. This time it dynamically detects the actual OS and prints the matching message. Section 25. While loop in bash, an alternative to for loops. We've already seen how to use a for loop to iterate through a range of numbers. But what if we need more flexibility in how we control the loop? Or maybe we want to perform an action while a condition is true? Solution. For that, bash provides the while loop. Let's start by creating a new bash script file. nano while.sh. As always, start with the shebang, number sign, /bin bash. Before using the while loop, we first need to declare a variable. Let's initialize I equals 0. This will be our loop counter, I equals 0. Now here's the syntax for the while loop. While double open square brackets $is less than 10 double close square brackets do echo, this is $I time done. The loop starts with while followed by a condition in double square brackets. It executes everything inside the do block and continues as long as the condition is true. Inside we use echo to print the iteration count. Section 26. What happens if we forget the increment? Let's say we forget to increment the variable I. What would happen? Let's test it. Run the script. Bash while.sh. The loop starts printing iteration number 0 repeatedly, and it never stops. Why? Because the value of I never increases, so the condition I less than 10 is always true. This is called an infinite loop. To stop it, just hit Ctrl+C. Now let's go back and fix it. Reopen the file and make sure to increment I inside the loop. Double open parenthesis, I plus equals 1 double close parenthesis. Now save and run the script again. This time it prints the numbers from 0 to 9 and then stops, just as expected. Section 27. Controlling the start point of the while loop. What if we want the loop to start from a different number, like 1 instead of 0? Solution. Just change the initial value of I. For example, I equals 1. Now, when you run the script, the output will start from 1 and go up to 9, stopping before 10. That's because our condition is still double open square brackets, $E less than 10 double close square brackets. Which means the loop will continue as long as I is less than 10. So whether you start from 0, 1 or any other number, it's completely in your control.
Section 28. Why use functions in Bash? When writing long Bash scripts, we often end up repeating the same blocks of code again and again. Solution. We can avoid repetition and keep our scripts cleaner by using functions in Bash. Functions allow us to group a set of commands and reuse them by just calling the function name. Let's see how to create one.
Section 29. Creating a basic function in Bash. First, let's create a new Bash script file, nanofunction.sh. Start with the usual shebang, number sign, /bin/bash. Method 1. Now I'm going to create a basic function named update to update system packages. Here's the syntax. Function update open curly bracket sudo apt update echo updating packages echo all packages updated close curly bracket. Before declaring the function, I'll also add an echo message above. Echo this is function script, just to verify if the script is running correctly. Now save the file and run it. Bash function.sh. What do you see? Only the message outside the function is printed. Why? Because we haven't called the function yet. Section 30. Executing a bash function. Even though we declared a function, it didn't run. That's because bash won't run a function unless it's called. Solution. Just type the function name after its declaration. Update. Save the file and run it again. Now you'll see the updating packages message, the system asking for sudo password. And finally, all packages updated. Awesome, our function worked. Section 31. Other ways to declare functions in Bash. Let me show you two more ways to declare functions in Bash. Method 2. Without the word function. You can omit the word function and use parentheses, update parenthesis, open curly bracket, echo, updating packages, sudo apt update echo, all packages updated, close curly bracket. It works the same way. Method 3. Single line function. You can also write the entire function in a single line like this. Update open curly bracket echo, updating semicolon sudo apt update semicolon echo, updated semicolon close curly bracket. Bash will throw an error. Just remember, use semicolons after each command in the same line. Run the script again, and all messages from the single line function will appear as expected. Section 32. Practical use of functions, wrapping an if-else block. Now let's apply what we've learned. Copy the previous if-else script and rename it. Copy ifelse.sh function example.sh. Open it using nano function example.sh. Wrap the entire if-else block inside a function called checkPackage. CheckPackage parenthesis, open curly bracket, your existing code here, close curly bracket. Don't forget to call the function after its declaration. Checkpackage, save and run the file, bash function example.sh. You'll see it works just like before. Checking the installation status of a package like curl. Section 33. Passing values to a bash function. What if we want to make this function dynamic and pass different package names each time? Solution. Use parameters like $1 and pass them both to the script and the function. First, let's update our script. Above the function, add echo. Value passes using variable to file is $1. Inside the function, replace all instances of $package with $1. Run the script bash function example.sh wget. You'll see $1 is captured outside the function, but inside the function, the value is missing. Why? Because we didn't pass it into the function directly. Section 34. Passing arguments to functions. To pass the same $1 value into the function, change the function call to checkPackage$1. Now inside the function, $1 will hold the package name. Run the script again. Bash function example.sh wget. Now you'll see. The package name is captured at the top. It's also used inside the function to check if the package exists. Perfect. You can now check any package dynamically by changing the value you pass to the script. Section 35. Bringing it all together in one script. Now that we've covered many bash scripting concepts one by one, it's time for a real-world example. You've learned how to use loops, functions, variables, if-else conditions, and more. But you might be wondering, how do I bring all these pieces together into one useful bash script? Solution. In this section, we'll combine all previous examples into a single dynamic script that checks for package installation and installs missing packages while tracking everything. Let's begin. Section 36. Copying the base function and loop. First, I'm going to copy some lines from the function example. Especially the for-in loop. But this time, instead of generic values, I'm changing the array items to Linux package names, because we want to check if these packages are installed or not. To do this, I'll also copy the logic from our earlier isPackageExist script. Section 37, connecting loop with if-else logic. In our for-in loop, we previously used $1 to represent the input. But here, since we're looping through an array, we'll use $I instead. Solution: update all references of $1 to $I within the function and if-else block. We'll also include an apt install command when a package isn't installed. But how do we check if the installation was successful? We'll use $, which stores the result of the last executed command. If it's 0, it means success.
Section 38, tracking the status of all packages. We want to know how many total packages we passed in array to install, how many were already installed, how many needed installation, how many were installed successfully, and how many failed. Solution will declare tracking variables at the top of the script. Total apps to install equals 0. Successful installation equals 0. Error installation equals 0. Already installed apps equals 0. Apps to install equals 0. Then we'll increment these values inside the loop at the right places. When the loop starts, increase total apps to install. If package is already installed, increase already installed apps. If not installed, increase apps to install. After install, if it was successful, increase successful installation. Else increase error installation.
Section 39, function call and final summary. We also need to call the function at the right place in the script. After the loop completes, we'll print a summary using echo statements. Echo total apps to install, $total apps to install. Echo already installed apps, $already installed apps. Echo apps to install, $apps to install. Echo successful apps, installation, $successful installation. Echo error installation, $error installation. For testing, I commented out the sudo apt install line just to ensure everything else works as expected. Save the file and run it. Bash final bash example.sh. Section 40, testing the script. We want to see whether our logic for counting and installing packages works accurately before running real installations. Solution: With the installation line commented out, you can safely check if your script runs correctly and prints the expected summary. Output should include update messages, each item in the array, whether it's already installed or not, and a final summary showing all counters. Right now it's showing all apps as already installed because installation is disabled. Section 41. Enhancing script output with item numbering. To make the output more user-friendly, I'm adding an app counter to display which app number we're checking. This counter increments at the start of each for-in loop iteration. Now when we run the script, we'll see. This is app1, curl, not installed, installing now. If installation is successful, it shows a success message. If not, it flags it as an error. Then it moves to this is app2, SSH, and so on. Section 42. Final test with installation enabled. Now let's remove the comment from the sudo apt install command and run the script again. Bash final bash example.sh. This time it installs any missing packages, displays status for each, and shows the final summary. Total apps to install equals 7. Already installed apps equals 4. Apps to install equals 3. Successful apps installation equals 3. Error installation equals 0. Each line is printed clearly and you can confirm every step right in the terminal.
And there you have it. We've gone through everything you need to know to get started with bash scripting. From simple if-else conditions, loops like for, while, and for-in, to working with functions, case statements, checking file and package existence, and even combining it all into one powerful automation script. If you followed along and practiced step by step, you now have a solid foundation to start building your own scripts. Whether you're managing a Linux system, automating package installations, or just exploring the power of the terminal. If you didn't understand something or feel like you missed any part, re-watch the entire video and practice alongside. That's the best way to master bash scripting. If you ran into any issues, got stuck on a part, leave a comment below. I'm always around and happy to help you out. If this video helped you, please consider giving it a like, sharing it with your friends, and of course, don't forget to subscribe to the channel for more practical Linux tutorials. This is just the beginning. There's a lot more coming up. Real-world Linux tips, automation, scripting, and hands-on fixes for everyday problems. So stay tuned. Only on Fix My Linux. Thanks for watching, and I'll see you in the next one. Happy Linuxing!